So as a geoscience, data science looking for ore deposits, one of the data sets that's available to everyone is public satellite information. So that's a first place to start, particularly in places unlike Australia that don't have large public data sets available, thanks to all our friendly geologic surveys that have done lots of work in the past. And here's a quick plug for the CSIRO's platform that you can get access to these sort of tools without having to build them yourself. I don't recommend building Kubernetes clusters for the neophyte unless you've got lots and lots of time. So that's where the title comes from. And there's a song reference or two in there if you like. So this is a combination. It's not quite as simple as what Tom was talking about. So there is a bit of coding involved here, but the bigger the data set and the more you have to do, the more you need more powerful tools to be able to access this. And thanks to another Australian organisation, Geoscience Australia and Digital Earth Australia, they produced a library called the Open Data Cube, which is for analysing satellite data. So that's very handy for us already. So the basic idea is you can take a time series, looking at the same spot in space, going back as far as the data is available, and this gives you the power to be able to analyse that, combine that, slice that, how you like. It's basically a combination of a Python library and a database to store the metadata. And once you get really large, so the important part for us is you want the best data you've got, so highest resolution possible that's available publicly. But the problem with high resolution is the bigger you get, it rapidly gets larger. When 100K scene over 1 day is 2 gigabytes, and you want to look at a whole country, for example, it gets very large. So you can't do it on one computer, you need multiple. So there's a Python library called Dask, which allows you to distribute the work over many machines. That's the simple version, and over many CPUs on many machines, with an interface that programmers and data scientists are basically used to in Jupyter Hub or Jupyter Notebook, if you like. So you can basically get access to as many machines, well, at least as a cloud provider like Amazon or Google have available, and you can afford. And so it's underpinned by raster processing in this case. There's another Python library there for that, and also a library called Xarray, which is taking arrays and giving them labels like data frames. So you can see like Y, X, band names, band 1, band 2, band 3. So you can slice and dice them with nice human-friendly readable things rather than row 17, column 243. So that's really great for looking at that. And you'll see that the distributed programming library breaks things up into smaller chunks to feed out to each machine so it can process part of them and then send it all back to you at the end. Open Data Cube process is basically tell it an area you want to look at over a particular time, the particular bands, in this case, Landsat, someone's wanting to look at the red, green and blue bands. You feed it, it goes and finds all the metadata for you, it gathers a data set and sets it up for processing. So when you have problems at this scale, you do not want to be downloading this, particularly not in Australia on an NBN, because you might live long enough. So you want to be able to process the data where it is. In this case, on Amazon S3 buckets. So all the files are there, you read the metadata from them, put it together, process it in a workflow that looks something along those lines. And so like all open source code, and the Jupyter Notebook Hub gives you an interface so that you can see what's going on, how many tasks are happening, whether your task stream looks healthy. You see on the bottom right there, it's like loading different bits of different bands of a particular different sentinel scene in that particular case. And you can end up putting together nice data sets that are literally made from hundreds of terabytes over as long a period of time or as big an area as you like, as long as you can split it up correctly. So many downstream uses of data sets like this, once you've got them available and done in a really cheaply and really quickly, like in the general, like, consultant project scheme of things. So thanks again to the CSIRO for making that much easier and much quicker than it would have been otherwise. So things like mineral mapping, you're looking for spectral end members to say, try and find signs of say chalcopyrite or something like that, something along those lines. And so you analyze the band, so you could also throw that into neural networks to do the same sort of thing. Improve geological mapping, where you start with what someone's mapped as a geoscientist and try and improve it a little bit. Now they're going to look quite similar, but generally speaking, you don't get nice freehand drawn lines when you wander around out in nature. It's going to end up looking more like that. So you might find parts of rocks you're interested in somewhere else. And multi-year time series over a very large part of Brazil. If you just grab a couple of scenes, join them together, you're going to see squares and splotches, and it's not going to line up. But if you can smooth it out, remove the clouds, take a long period time series median or geometric median to get more complicated, you end up with a really nice, great data set you can do lots of good things with. And that is basically it.